Hello students, welcome to EPG Pathshala. I am Dr. Sanjay Mishra from Department of Business Administration, Faculty of Management, MJP, Rohilkhand University, Bareilly, UP. Today we are going to discuss about the module Measures of Central Tendency, Mathematical Averages, Arithmetic Mean, Geometric Mean, Harmonic Mean, under the paper Quantitative Techniques for Management Decisions. After studying this module, which is very important for a management student because it helps or it supplements the subjective decision making of a management student or a manager with the objective facts. So after studying this module, you will be able to understand the concept of measures of central tendency, particularly arithmetic mean, geometric mean, harmonic mean. And you will also be able to understand the different methods which are used for calculating AM, GM and HM. We will also be discussing the merits, demerits and the situations where these different measures should be used. And finally, we will be looking at the relationship which exists between arithmetic mean, geometric mean and harmonic mean. All of you must be aware, or you must have seen, or you must have read many statements which are discussed. Say there was a statement regarding IMF predicts a growth rate of 7.6% for 2016-17 and 2017-18 for Indian economy. This statement, you must have read it in newspaper or some journal, or you must have listened it on television set while discussions were taking place. Or you must have heard people talk about average income of area is 15,000 per month, whereas average income of some other area is 20,000. Or a common statement is students study on an average for 4 hours after the classes, or 8 hours, or something like this. Or we talk about wages of workers in factory X are rupees 10,000 per month. Now, when you look at these statements carefully and you try to decipher the meaning which is lying below them, then one thing which becomes very clear to us is that these statements are not talking about some extreme value or figure. You talk about, say for example, the average income of workers in a particular factory. We say it is 10,000 rupees. What does it mean? Everyone is getting, each and every worker is getting 10,000 rupees? No. Or does it mean most of the workers are getting more than 10,000? No. Or they are getting less than 10,000? No. Then what does it mean? It means some central value. Not an extreme value, but some central value around which most of the observations, that is a wage around which most of the workers will be getting or having their income. So it lies at the central. So when we look at it, we feel that this is one value which represents the situations, economic conditions of the workers. We feel that this is a representative value for the workers, or a representative value for the data, whatever the data is. That's why this value is known as measures of central tendency. It provides us with an idea about what the data is trying to convey. That is one value which gives you an idea about the whole country, about the whole state, about the whole industry, about the whole factory, about the whole college, depending upon what we are looking at. If we are looking at, say, the average income of Indians, it means we are talking about an income around which most of the people in India are having their income. Or if we are talking about the average income of people in Delhi, it simply means a income around which most of the Delhites have their income. It doesn't mean that we are talking about the Ambanis, or we are talking about the Ratan Tata, or we are talking about somebody who is on the street, a beggar. We are talking about a central value. So that's why we call them as measures of central value, or measures of central tendency. Now this average value or middle value or most frequent value, people informally call as average, but the true term is measure of central tendency. We will discuss about the three measures of central tendency: arithmetic mean, geometric mean, harmonic mean. These three different measures are used in different situations depending upon the problem which we are confronting. Most of the time, we make use of arithmetic mean, but there are situations when arithmetic mean is not suitable. We go for geometric mean or we go for harmonic mean. Arithmetic mean. Arithmetic mean is a very common measure, and normally people consider average to be arithmetic mean. But for a person who is well versed in statistics, arithmetic mean is different from average. Average is a broader term which includes all other measures also. So what is arithmetic mean? Arithmetic mean is sum of observations divided by the number of observations. And in order to calculate arithmetic mean, we make use of two methods. One is known as direct method and the other one is known as indirect or shortcut method. Direct method. Now, when we make use of direct method, we have to look at the data whether it is grouped or ungrouped. Ungrouped data means that only the values are present and there is no frequency attached with individual values. So arithmetic mean in this case is x1 plus x2 plus xn. That is, you are writing down the individual observations, you are summing them, and then you are dividing it by n. That is the number of observations. So we can write arithmetic mean as summation x divided by n. Let's look at an example. Suppose we have to find the arithmetic mean of marks obtained by students in a test. Say the marks are 61, 81, 87, 78, 54, 56, 67, 65, 68 and 69. So in order to calculate arithmetic mean, first of all, we sum all these observations from 65 to 69 and then divide it by the number of observations, that is n. In this case, n is equal to 10. So if we sum the observations, we get equal to 690 and n is 10. So arithmetic mean comes out to be 69. Now let's talk about group data. Group data means that we have classes and there are frequencies. Suppose we talk about income of people and the classes are say 0 to 5,000 and there are 10 people. So frequency is 10. 5,000 to 10,000, say there are 8 people. So frequency is 8. So if the data is given in this form, then it is known as group data. So if we are having group data, first of all, we find out the midpoints of different classes, that is x1, x2, xn, and then we try to multiply these mid values with the individual frequencies. That is, if I talk about the first class, the product is f1 multiplied by the midpoint x1, so it is f1 f1. If I talk about the second class, midpoint is x2, so product is f2 x2. And if I talk about the last class, midpoint is xn and frequency is fn. So product is fn multiplied by xn. So we sum these values from f1x1 to fnxn. This is known as summation fi xi. And we divide the sum by the sum of frequency, which is capital N. Summation fi equal to n. Now let's explain this concept with the help of an example. Suppose we are trying to find out the average number of children per family in a particular area. Now when we go for survey, we find that there are 30 families which are having 0 children, 52 families having 1 children, 60 families having 2. This way, the frequencies are 30, 52, 60, 65 up to 5. And the value of x, in this case classes are not given, directly the values are given. So the value of x is 0, 1, 2 up to 6. So first what we do is, we try to find the product of fi xi. That is, we multiply f1 with x1. f1 in this case is 30 and x1 in this case is 0. Then we multiply f2 by x2, that is 52 into 1. And lastly, we multiply 5 by 6. So the sum comes out to be, summation fi xi comes out to be 519. Next, we find out the sum of frequencies. Sum of frequencies is summation fi, which is equal to capital N, and it is equal to 240 in this case. So what is arithmetic mean? It is summation fi xi upon n, that is 519 divided by 240. It comes out to be 2.1625. Now let's talk about the second method, which is used for finding out arithmetic mean. This method is known as indirect method or step deviation method. The basic objective behind using this method is to simplify the calculations. Sometimes when we try to find out the arithmetic mean directly, the calculations are a bit cumbersome or a bit complicated. So we can avoid these complications if we make use of indirect method or step deviation method. Sometimes this method is also known as shortcut method. So let's start with ungrouped data. In case of ungrouped data, arithmetic mean x bar is equal to a plus summation di upon n, where di is equal to xi minus a. In this case, a is known as assumed mean. By assumed mean, what we want to convey is that we have shifted the origin from 0 to a. Now let's talk about group data. In case of group data, arithmetic mean x bar is equal to a plus summation fi di divided by capital N, and this is multiplied by h, where h is the class interval or the width of the class, and di is equal to xi minus a upon h. So in case of group data, what we are doing is, we are shifting the origin and we are also changing the scale. Now let's explain this point using an example. Suppose daily income distribution of 500 workers is given, and we have to find out the average income or arithmetic mean. Income in this case is 0 to 50. This is the first class and there are 90 workers. Second class is from 50 to 100 and there are 150 workers. Third class income is from 100 to 150 and there are 100 workers. And last class is from 250 to 300 and there are 10 workers. This is group data. So if we are using shortcut method, what we do is, we make use of the formula a plus summation fi di upon n into h. In this case, First of all, we have to calculate the value of di, which is equal to xi minus a upon h. In this example, xi is the midpoint. Midpoint means if I talk about the first class 0 to 50, x1 will be 25. If I talk about the second class 50 to 100, midpoint will be 75. Third class 100 to 150, midpoint will be 125. So this way we calculate the midpoints and then we find out di. Di is equal to xi minus 125 divided by h. A is 125, it is assumed mean, and h is width of the class, which is 50. In this case, when we try to find out summation fi di using the calculations, it comes out to be minus 80, and capital N, which is sum of frequencies, it comes out to be 500 since 500 workers are there. So putting these values in the formula, we get arithmetic mean is 117. That is, the average income is rupees 117. Now, we will look at what are the plus points when we use arithmetic mean as a measure of central tendency. Or as we know that in 90% of the cases or more than that, whenever we are talking about some average, we are talking about arithmetic mean. So what is the reason? In order to find out the reason, we must look at the merits which arithmetic mean possess as a measure of central tendency. The first and the most important thing is arithmetic mean is very easy to understand and calculate. Even to a layman, if you say that what is arithmetic mean, it is sum of observations divided by the number of observations. So he can get the idea. So it's not difficult. Second thing is arithmetic mean is based on all the observations. That is, if you talk about the income of the class and say there are 60 students, then you have to ask each student what is their income. You find out the sum of these 60 students' income and divide it by 60. Now say the average comes out to be 30,000. Now if you change one value, if you exchange one student with some other student, say of some other class, then the value of arithmetic mean is going to change. That is what is meant by based on all the observations. Third plus point of arithmetic mean is it is rigidly defined. Rigidly defined in the sense anyone, any person using same set of data and calculating arithmetic mean will arrive on the same figure. It can never happen that Mr. X for data or Mr. X for data of country A calculates arithmetic mean, it comes out to be 10,000, and when Mr. B uses the same data, arithmetic mean comes out to be 30,000. It can never happen. That's why it is said that arithmetic mean is rigidly defined. Another plus point is that arithmetic mean is capable of further algebraic treatment. That is, if you know the arithmetic mean, you can use it for further analysis. Say for example, if you know the arithmetic mean of one state, say Uttar Pradesh, average income of UP, and you know the average income of say another state, suppose Madhya Pradesh, MP, then using the arithmetic mean of UP and MP, you can calculate the average income of the two states combined. This is what is meant by that arithmetic mean is capable of further algebraic treatment. Lastly, and very important point, very plus important point is that arithmetic mean possesses sampling stability. By sampling stability, we mean that if you change the sample, normally what we are doing is we are studying a small portion in order to draw inference or some conclusion, say basically about the bigger group, that what we call as population. Suppose if you are interested in finding out the average income of Delhi people and you take a sample of 1,000 people and you find out the arithmetic mean, say it comes out to be x1. Then you draw another sample of 1,000 people from Delhi and you calculate the arithmetic mean, say it comes out to be x2. Now the difference between x1 and x2, if the samples are representative. The difference between x1 and x2, that is the average of first sample and second sample, it will be less, right? This is what is meant by sampling stability. Now let's talk about certain demerits of arithmetic mean. Why in certain situations we don't use arithmetic mean? One important demerit is that arithmetic mean is unduly affected by extreme values. Say again, if you go back to the example of average income of your class, there are 60 people in the class, all are sitting, I ask your income, you tell me your income, say it is 60,000, you say 50,000, you say 40,000, you say 80,000, and say the average income comes out to be around, say, 55,000. Now, if I replace a student, maybe with the son of a billionaire, right? Then what happens? All of a sudden, the income of this class, it goes up and it becomes, say, 1,50,000 or 2 lakh or 3 lakh, whatever it is. So the point which I want to emphasize is because of this one extreme value, it gets inflated. So what happens is that one extreme value is unduly affecting the arithmetic mean. This is one drawback of arithmetic mean. So whenever you have a situation where extreme values are present, never use arithmetic mean. Second drawback of arithmetic mean is that it cannot be calculated in case of open-ended classes. What it means is, suppose you are having group data, that is the classes are given. It starts from 0 to 5,000, 5,000 to 10,000, 10,000 to 15,000, and the last class is 45,000 and above. Now you cannot find out or calculate arithmetic mean, because in order to calculate arithmetic mean, you require midpoint. How you are going to find the midpoint of the last class? This is another important drawback. So whenever these two cases are occurring, that is you are having extreme values or you are having open-end classes, don't go for arithmetic mean. Now we will discuss about another important measure of geometric mean, because we cannot use arithmetic mean in all the situations. There are certain situations where geometric mean provides a better answer. Say for example, if we are interested in measuring the average rate of change over time, the phenomena involved could be the economic growth, it could be the percentage increase in sales or production or anything. So here better option than arithmetic mean is geometric mean. So how we calculate it? Say for example, if it is ungrouped data, that is frequencies are not there, only the individual values are given. So geometric mean is equal to x1 multiplied by x2 multiplied by x3 up to xn. That is the product of all the observations, and then we take the nth root of this product. So geometric mean, if we try to calculate it directly, it is a bit difficult, it is not easy. So in order to calculate geometric mean, we make use of logarithms. So when we make use of logarithms, what we do is we say log geometric mean is equal to log of the product of the numbers raised to the power 1n. So geometric mean will be antilog within bracket 1 upon n summation log xi. Now if the data is grouped, that is we are having frequencies and we are having the midpoints x1, x2, xn. So geometric mean will be x1 raised to the power f1 multiplied by x2 raised to the power f2 multiplied by, and lastly xn raised to the power fn. And then we find out the nth root of this product. So after this we apply log and antilog, and finally we get geometric mean equal to antilog within bracket 1 upon n summation fi log xi. Geometric mean, as we have already discussed, that it is best suited when we try to find out average percentage increase in sales, production, or some other economic or business raise. Theoretically, geometric means are considered to be the best average if we are constructing any index number. Harmonic mean. Harmonic mean is used as a measure of central tendency in cases where we are interested in finding out rates. Rates means any phenomena where two units are involved. Say for example, speed. When we talk about speed, there is distance and there is time. Say distance could be in kilometers and time could be in hours. So harmonic mean is used in case of phenomena where rates are involved, that is two units are involved, and in this also we make use of harmonic mean instead of arithmetic mean when the numerator is constant. Say for example, if we have to find out the speed, average speed, and we are interested in finding out how Mr. Rahul, a student of MBA, at what speed he traveled from his house to the institute on his motor bicycle. Say the average speed from house to institute was 40 kilometers. And say went back to his house, say the average speed from institute to house was 60 kilometers. In this case, if we have to find out the average speed, we will be making use of harmonic mean because the distance traveled, house to institute and institute to house, is same. So harmonic mean is used when the numerator is constant. So how we calculate it? Harmonic mean, basically it is defined as the reciprocal of the arithmetic mean of the reciprocals of the individual observations. For ungrouped data, harmonic mean is equal to n upon, within bracket in the denominator we have 1 upon x1 plus 1 upon x2 and lastly 1 upon xn. We can write it as harmonic mean equal to n upon, in the denominator, summation 1 upon xi. Now let's explain harmonic mean with the help of an example. There is a cyclist who pedals from his house to his college and average speed is 12 kilometers per hour. And then he goes back from the college to his house at average speed of 15 kilometers per hour. So what is the average speed? Since the distance is same, so we will be using harmonic mean. So average speed is equal to n upon, in the denominator, summation 1 upon xi. So we have to find out the value of 1 upon x1 in this case plus 1 upon x2. x1 is 12 and x2 is 15. So it comes out to be harmonic mean or average speed comes out to be, when we put these values in the formula, it comes out to be 13.33 kilometers per hour. Now let's talk about group data. That is, we are having a data where there are classes and there are frequencies. So first thing is, we will find out the midpoints of different classes, that is x1, x2, xn, and then we will apply the formula of harmonic mean. In case of group data, harmonic mean is equal to summation fi divided by, in the denominator you have within brackets fn upon x1 plus f2 upon x2 and last is plus fn upon xn. So you can write it as capital N divided by, within bracket in the denominator, summation fi upon xi. Now let's talk about the uses of harmonic mean. Harmonic mean is used for calculating averages where two units are involved. Say for example, average speed at which a journey has been performed. So if you look at speed, it contains two units. In the numerator, you have kilometer and say in the denominator, you have hours. Now, the merits of HM or harmonic mean. First merit is that it is based on all the observations. If you look at the formula, it is summation n upon summation 1 upon xi plus and last is 1 upon xn. So if you change any observation, harmonic mean is going to change. Second plus point is it is less affected by extreme values. Third is it is strictly defined or rigidly defined. Now let's look at the demerits. Harmonic mean, if you compare it with arithmetic mean, it is not simple to calculate and easy to understand. And second thing is it cannot be calculated if one of the observations is 0, because 1 upon xi, and if xi is 0, it becomes a problem. So now let's summarize what we have discussed in this module. One thing is these measures of central tendency gives us an idea around the central or of the central value around which most of the values are clustering. These values are considered to be representative values, that is the values which represent the data. AM is the most common measure of central tendency, which is obtained by adding all the observations and dividing the sum by the number of observations. Geometric mean is used for measuring the average rate of change over time. It is defined as the nth root of the product of n items or values, whereas harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocals of the individual observations. Thank you.